Kubernetes is an open-source container orchestration platform that automates the deployment, scaling, and management of containerized applications across clusters of hosts. It has been growing in popularity ever since its release in 2014 and is now the go-to choice for all tech bros looking to serve their innovative AI startup to 100 monthly visitors. Deployments and infrastructure in Kubernetes are defined using YAML, which is the only human-readable data serialization language in existence which no human can actually read. These YAML-represented Kubernetes resources are called manifests. Manifests come in different kinds, representing various different resource types, and are stored inside the cluster control plane. Kubernetes resources are declarative, meaning that they represent a certain desired configuration state which Kubernetes is in turn responsible for orchestrating and maintaining. A Kubernetes cluster consists of one or multiple nodes that are managed by a single shared control plane. Each node represents a single virtual or physical host within the cluster, capable of running containerized workloads, and is usually a virtual machine or some other kind of server. Nodes come in different shapes and sizes, and with different hardware capabilities, all of which Kubernetes can use to make decisions on how and where to distribute the cluster's workload the most efficiently. While you can think of nodes as dividing clusters into fragments at a hardware level, namespaces in Kubernetes allow us to split things at a logical level. The majority of resource types in Kubernetes can be grouped together into namespaces. Apart from keeping things organized, namespaces offer important security benefits as they allow for finer control to various parts of the cluster, and also make sure that certain resources cannot access each other across two separate namespaces. The smallest deployable unit in Kubernetes is a pod. It represents a single instance of a containerized workload. A pod usually consists of a single container, though multiple can be bundled together for more advanced functionality. Pods are generally considered ephemeral and stateless workloads, which is why they can be configured with health checks that tell Kubernetes how to periodically check that your pod is functioning correctly, allowing any faulty ones to be automatically replaced. Deployments are used to define a set of desired pods by configuring a pod template, the desired amount of pod replicas, and various other options to configure pod behavior. Deployments and pods are just one of many examples of parent-child relationships between resources in Kubernetes, with the deployment being constantly responsible for ensuring that the desired number of pods is up and running. Config maps and secrets can be used to store arbitrary data in the cluster, which can then be consumed by pods at runtime. As the name suggests, config maps are intended for non-sensitive values such as runtime configuration, whereas secrets store sensitive values such as API keys or tokens. Both config maps and secrets can be mounted into pods as either environment variables or entries in the file system. Services are a networking abstraction used to group a set of workloads behind a single, stable network endpoint. A service will automatically distribute traffic to all the pods within its scope, taking into account their readiness to serve requests. Workloads within the cluster can access services exposed by other workloads, allowing them to be used for network calls across different applications. This makes services a useful tool for establishing network connections between different applications, all without ever leaving the cluster. While services are used to expose network endpoints inside the cluster, an ingress can be used to define an external network entry point for connections from outside the cluster. Ingress is a generic API, and the implementation will differ based on Kubernetes distribution in question. However, ingresses most often represent some form of load balancer that processes network requests from outside the cluster and routes them to one or more underlying services. Hope you found this rapid-fire Kubernetes rundown useful. Let me know down below if you want me to make a video covering more advanced parts of Kubernetes. See you in the next one.